So, welcome everybody. My name is Søren Salomo, and I'm head of department at DTU Management Engineering. And that's also, well, obviously it's a department at DTU, and we can welcome a new DTU professor today with an inaugural lecture by Anja Maier, who has sit in front here and is very nervous, I notice. But there is no reason to be very nervous. I know that you will do a good job here. Anja is our most recent professor at the department. And her research focuses on engineering systems design, with a, she told me, particular emphasis on complexity and human behavior, which I don't really think is really specific, because that sounds very, very broad to me, but you will come back to that much more, I know. She is looking at, amongst other things, design communication, and interesting enough, spans broadly across different application areas or industries. It goes all the way from aerospace to healthcare and information technology. She will touch upon some of our projects today. For example, variable sensing technology to the elderly with dementia, which is a collaborative project with Glostrup Hospital. And when I counted last, in fact, if you look at the department overall, healthcare is probably one of our most dominant areas in which many share an interest, and so does Anja. Obviously with a specific focus on engineering systems. But she has additional projects. She is collaborating with Technical University in Munich. When I say Munich here, I forgot that I really wanted to start in German. I thought that would be a nice touch, but let's just keep it in English. So she collaborates with Munich around visual modeling of complex engineering systems, and this aspect also goes into a project with the OECD Nuclear Research Facility in Halden. Also on visual communication, though, however, in this scenario of emergencies. So she spans broadly. As I said before, she's giving her inaugural lecture today, and there's a slight little formal part, and I'll come to that now, because I have to mention a little bit the way you went until coming here. Anja has a Master in Science degree from Universität Münster, 2002, and in fact already started working at IBM, if I recall correctly, at IBM, and continued working for IBM in quite a senior position afterwards, until she figured out that there must be more in the world, and that there are other paths where you can make a bigger impact, and wisely chose to take a PhD. And then was accepted from University of Cambridge, and took a PhD degree in engineering design in 2007 at Cambridge University. She continued working there as a research associate in engineering at the Engineering Design Center for approximately 3 years, until she, in 2010, joined DTU as an associate professor in DTU management at that time. Since then, she's been working here at DTU with great success. She has been nominated several times for the Best Teacher Award at DTU, which is tough to get because there are really a lot of good teachers. So I think the runners-up list is really, really good. In particular, I've on it several times. And I'm sure you will win it also in the coming future. And then, as of July 1st, been appointed professor in the topic of engineering systems at DTU. So you are a DTU professor already, so it's more a formal point here. Besides that, she stretches broadly. I mentioned already TU Munich, where she has been a visiting professor, but she's also been a visiting professor at MIT. Most importantly, maybe in this context here, she is also a group leader of a newly established group, which has turned out to be a division now, a larger group at the Department on Engineering Systems, and managing this group. And it is, not the least, due to Anja that we have this group now, the effort of binding these people together, bonding them together, you should probably say, around the topic of engineering systems. And if you wonder what that is, I'm sure she will tell you a little bit more in a second. So we're really happy to have Anja at the department. I'm really proud that we have Anja as a professor, full professor at the department, and I'm also looking really much forward to your inaugural lecture. So give Anja a great hand.
Thank you, Søren, for this introduction. Thank you also to the directorate of this university, here represented by Maier, Senior Vice President, Innovation and Entrepreneurship, for the opportunity to give this talk today. So welcome all to my inaugural professorship lecture on designing engineering systems. And what a fine place this here is. DTU Skylab, DTU's incubator, where it all begins. I'm sure you saw the slogan when you entered through the door. And so what I will begin to do now is start to share my vision of the field with you, and also some of the current research projects that are ongoing. And I'll take you from observations, how I see engineering unfolding, to engineering systems as the field and also what's happening here at DTU, and then specifically on my area of designing engineering systems. So, when preparing for this lecture, I realized that I've been living at the same place for almost 6 years, but it's by far not the same space. And so, for about 1,000 days, going to DTU in the morning, I've been looking at this view. And so here what you see is a view from Nordhavn Station, overlooking the Öresund, the water between Sweden and Denmark. And what I see on this photograph, taken just recently, is certainly not what I saw when I started. And you can see in the back, you can see wind parks, you can see the passenger ferry to Oslo, probably equipped with the latest scrubber technology, am I right? Also, you can see or imagine people operating the cranes, preparing the ground, erecting new buildings, for example, the UN city here, 45,000 square meters of office space, several football pitches as a comparison. And all these designing efforts that are around us impact us for a long time. So we're really designing for the long haul here. And you can also imagine the project management efforts that come in, the regulators and government that is involved, and it's really changing our lives for the long haul. And so from these general or personal observations, I have some general observations on engineering, and you will see how this actually colors sort of my way on how I take engineering systems. One is I see the role of engineers changing. And here I don't directly mean sort of all the new developments on mobile communications or new production technologies or new work patterns that arise from that. What I mean by that directly is the type of knowledge and insight and foresight that engineers have to have, in addition to their traditional engineering skills, is broadening. And Søren mentioned this sort of broad, and here we see it. You, as an engineer, you've got to be part lawyer. There's safety concerns. There's also intellectual property rights that you may want to be thinking of, especially when you're starting your venture. That leads me to the other point. You need to be part MBA, quite business savvy. Also, you're dealing with humans, and that's not necessarily overly predictable. And so all this knowledge, or all this requires you as an engineer to make use of knowledge that is outside the traditional engineering domain. Secondly, what is also happening is that engineers, especially design engineers, tackling much larger challenges than they used to do before. So this is also going beyond the traditional engineering realm. Think of disaster recovery, think of smart cities, think of healthcare provision. So here, again, we're doing something different than we did before. And this requires also to have this sort of systemic outlook. And I see the new breed of engineers emerge here. And this is really, we are in an era where engineers are looking much broader outside the traditional engineering realm. And from all this, it is my vision to create this hub of researchers, integrating multiple disciplines, tackling large-scale and complex challenges, and thus transforming society. So this is my vision for what I want to create here at DTU. And this has, of course, also, and the developments that I just sketched have implications, of course, also for the research. We're seeing our research object move. The new areas that we're tackling, this requires also to adapt with our research methods. It's much more data-driven, it's much more experimental. Yet, of course, we do ethnographic studies in order to have the ecological validity also in place. So we are adapting as well. And of course, education, there's a new demand in education here as well, and so on. So having sketched my vision for you, from here forward, I've composed the talk in two parts. And one, I'll give you an introduction on engineering systems and also what's happening here. And then I'll focus on current research projects that I've brought with me today to share with you. Leading up to the definition of engineering systems, let's look at healthcare. And what you see here is, or are, a number of technical artifacts. The bed, the hinges in the bed, the bedside table. You'll see bedside monitor, complex mechatronic devices monitoring vital parameters. You see a smartwatch here on the sideboard. And of course, what you now think is, yeah, all right, what else? We have, of course, the people, and this is what I want to add. There's sort of the socio side. We have a number of different stakeholders here. We have the patient, we have the doctors, the nurses, the children, the patient's family. You can also see a little dollar sign here, so you have the hospital management. You can think of also insurance companies. Outside hospital, the caregiver's home or the patient's home. So from all these elements, we have a lot of organizational complexity as well. But what's happening here is, of course, the interactions. And we, as design engineers, all of a sudden, we're finding ourselves designing those interactions. And this is something that we intently do, but it often also evolves. So there's partial design and partial evolvement. And this is what's really challenging, designing those connections, be it through information flow or otherwise. And this is something that leads us to the definitions that we've borrowed and adapted and being inspired by colleagues from the US. So engineering systems understood as socio-technical systems that fulfill important functions in society. So for example, improving our health, transporting people and cargo, managing global manufacturing across the value chain, providing energy, building and maintaining critical infrastructure, and so on. So these large-scale systems, and what they characterized by, what cuts across, are three elements, you could say. One, there's high interwoven technical and organizational complexity at play. We have multifacetedness of human behavior, as well as these uncertainties of long life cycles. And these challenges, these three challenges, you can also argue they are levers to improve, but this characterizes the large-scale systems that we want to tackle. And as already mentioned, it's partially designed and also partially evolved. So you can then say, okay, this is a definition of systems, but what it also is, engineering systems, is a perspective based on system thinking, a perspective in engineering that realizes that most of the challenges we're tackling today, that they don't have a purely technical solution, and that it involves technology, processes, and policies. And so from this sketching of the definition of the area, Søren already mentioned at the start, we have formed a group, and this is the team. So roughly 2 years ago, we had the opportunity to found the Engineering Systems Group to research and develop knowledge and understanding, methods and tools for better functioning systems, more sustainable systems, and also to higher quality. And what our unique proposition is to tackle the challenges, the complexity, the human behavior, and the uncertainty by integrating 3 areas, and this is design, management, and aligning business strategy with public policy. And those areas, you could argue, are often separate. But what we're doing is, when you design, you have to think of the implications for management, and policy gives you also the regulatory framework often gives you a frame for the designing. So there's always these interactions. And this is what our framework looks like, what we're doing. And now, from here forward, as I have the pleasure of being the head of the division, and I will now, from here forward, show you in this lecture the research projects coming from the design side. So from here forward, this is entering the interdisciplinary design of engineering systems. I've brought 4 projects with me for you to share. Before I do that, I want to look into the definition of designing that I'm employing. And ask engineering design professors, and there's a number in the room, and you'll get probably different answers. So I quite like the definition used or put forward by Herbert Simon, Nobel laureate, and he's quite, he's equally recognized for his works on the organization of complexity, but also bounded rationality and the sciences of design. And so what he says is that everyone designs who devises courses of action aimed at changing existing situations into preferred ones. So what I quite like about this definition is that it implies that you have some understanding of your environment around you. At the same time, you have to understand the unmet needs. And also, there's an aspect of improving what there is today in going forward. So design for me is actually inherently also about creating transformations. So from this, I've brought you 4 research projects. And why I've selected those ones is also to show that there's different levels of investigations here in this field. And let's start with the bottom left-hand corner here, the icon. Wait. The icon. We can investigate on the level of the individual. We can look at an individual person's cognition, or designer's cognition, or user cognition. We can go up the circle clockwise and scale it up to the organizational level, look at interfaces between departments or the whole organization, and we can even scale it more up at the level of the whole industry. And the first project on designing human-centered healthcare touches on all 3 levels. And then the subsequent projects, one looking into sort of a methodological aspect with an industrial application that I will show you on visual reasoning. Designers use a lot of drawings, a lot of diagrams. So it's a core aspect of designing. And then the third project looks at improving design processes, and the 4th one at sustainable production in the whole industry in Denmark. So looking into designing human-centered healthcare. What we see, what everyone sees, is the demographic change nowadays. There is an aging population, and this is impacting health service provision. It's also a cost matter, and maybe a social burden in some ways. But what we're asking us is, can we cater for scale? At the same time, how can we personalize healthcare? And to give an example, we can take dementia care. There is today around 90,000 people suffering from dementia here in Denmark, 50,000 of which around Alzheimer's dementia. But the numbers are projected to rise to 160 thereabouts in 240. So in only 25 years' time, if we equate it, we could say the whole of Aalborg and the whole of Bellerup so the numbers are that high. It's really something that we need to care for. And this idea of the foresight here now and caring or working towards a more personalized healthcare setting could be a way forward, a participative healthcare. And we're not going to build new super hospitals, probably. So we need to find a different way. And one of the ideas is we are working together with the hospital that's been mentioned. The idea is to maybe look into active aging through technology. So this is the other trend that we see in society. We have a lot of technological breakthrough. So can we combine these areas? And we're seeing an increase in interest by the clinical side in using technologies. And often, of course, the cycle, sort of the medical or clinical evidence cycle is a bit asynchronous of the fast-paced technological evolution. So there's also this aspect here that we need to consider. And looking at using personalized healthcare technologies in order to help elderly with dementia is specifically a project that Julia is working on. And here we want to look into whether sensing technologies can help towards active aging, as in keeping the elderly included in society and thereby maybe lower the caretaker burden, and also make sure that we don't need to build semi-more hospitals, but that we have other ways of including people in society. So this area of mental health is something that is of vital importance in society. Also, the idea of having non-pharmacological interventions. This is something that the medical field is really opening up, especially in the field of cognitive rehabilitation. So there we have this opportunity as engineers to contribute very, very directly towards designing for life. And so what we do here is not only giving functional support to the patients, but also we want to enable healthcare professionals like doctors and neuropsychologists and nurses to possibly have another way of getting information for their diagnosis or for the treatment. So at the moment there is this idea there is qualitative feedback from users and caregivers that we look at, but also of course standard assessments. But maybe this data that is logged on the devices could give us another idea, a more ongoing measurement rather than spot measurements of how the disease is progressing or how much people are included. And so for us is understanding human behavior. Here's the human behavior side. In this case, it's the user behavior. What are the motion patterns? What are the embeddedness in society patterns, the communication, the logged interactions? We want to go further with this as well. So from the individual personalized, we want to look into a whole healthcare system design. And implementing there, the questions that we ask now is implementing technology. This adoption and acceptance, this is not given for granted. We look into stakeholder networks. When you implement a new technology, it changes how interactions happen, it changes interests. Also to look into a more connected and collaborative care model through not only the personal connections, but also the data connections that we see. So how can we distribute the data so that it's available beyond just the patient and the caretaker? And here, if you look very detailed into this diagram, you can see that there's maybe a few things that have been added, so the Ministry of Health or the ambulance. So there's a number of places that we need to also distribute this data to. But what connects the two sides, on the one hand, the personalized adapting of wearables, but also the whole healthcare system design, is this idea of also analyzing and visualizing and communicating data to inform diagnostics, to also better design a system. And so for us, on the one hand, this is interesting because, as I said, the engineering design research field is changing. It's using much more data-driven investigations. But for me, this is also interesting because it connects to this whole idea of visual reasoning. And this goes all the way back to my Cambridge heart, if you like, looking into design communication. And very roughly sketched here to introduce is to say, well, you have your system, and it's, for me, essentially about integrating different views. You make a model of that system, And that model, for example, if I model the healthcare system as a connection between people and their information flows, this is one way. But someone else may model the system as financial or time sequences. So all these different views need to be integrated, and what's not in your model, you're not going to work on. So you have your diagram of visualizing that model, and then that impacts human behavior. What's there, you will do or not. So going very detailed into some of the studies on visual layout, and bear with me, you will, after a couple of slides, know where this is leading and see that this detailed will have an impact. So here, this particular study is going onto layout of diagrams. So it's going even deeper into the visualizations. And here we used eye tracking to follow the eye movements of participants and to see what happens when they look at certain system diagrams. Do they understand what's on the diagram? Can they perform fast? Is there high or low cognitive load? What reading patterns do we see? And whether there's differences between novices and experts. So what the results, or some of the results were, is firstly, very clearly, layout does matter. So the way you actually structure your diagram has an impact on how people will understand it. And nowadays we have a lot of layout algorithms. So you don't even think of, when you model, you don't even think of it anymore, but it does have an impact. And what's interesting is that line bends and crossings, they take up as much space as other elements in the diagram. So you really have to be very detailed and pay attention to how you set up your visualization, even with the lines. And good layouts are more beneficial to novices, so they benefit more when it's good. Experts have maybe some coping strategies, but you can also say, we found, and this was interesting, that novices in general have a much lower cognitive workload when looking at diagrams. And that makes me think, well, what else is going on with the experts? You know, what else is there in the brain whilst they're looking at diagrams? So that would be an interesting way to look further. Now with the reading strategies, you know, how do we explore a diagram? What do we do? And we found 3 patterns. One is that people follow the diagram flow that is there naturally. So if there's directed or undirected edges, so they flow along the arrows, they will probably do that if you give this intention. Secondly, we saw text flow. And this is maybe our Western's habit that we look from top left to bottom right, yeah? So that's how we read. Maybe one explanation. And then we also found random walk. People traversing the diagram in no particular order, and this was especially for novices. So this is shown through the scan path visualization. And why this is of importance is there's a lot of requirement elicitation practice in design, a lot of handover scenarios, communication through diagrams, reading of diagrams, and decision making. And this has an impact, and especially we are now starting a project in the nuclear sector, and Emil has just started his PhD a couple of days ago on this, where there's high importance of how visual or how information is displayed and how the operators make the choice, make the decision. And so to stop looking, providing errors, so to speak, but to foster a better way of making appropriate decisions. And so, I mean, we have neighboring countries that still have nuclear reactors. So I think we do need to look specifically at the visual communication design, the specific layout of information that is needed during emergency situations. And so this emergency, the area of designing for emergency situations is also a new engineering area for us here. And what we want to do is very specifically look at visual attention and cognitive workload to help the operators make the appropriate decisions. And this, I'm quite glad that specifically this comes to light now, and that our research partner is very interested in these very detailed specific studies using eye tracking or other physiological measurements, so we can provide for appropriate decision making and other human behavior. And it comes also that post-Fukushima, there's now a requirement to really have clear protocols in place for emergency situations. Taking you now from the individual level to the organizational level, looking at the design process in a designing organization. And here in specific, we'll still stay with the theme of energy, but this is a biomass power plant that you see here. And here we're working together with a company whose site is not so far away from DTU, and I saw our collaborator also in the audience. So the idea here is to say, how can we improve our currently running business, the operations? For example, if you want to roll out the design of that plant, the boiler and so on, in another site. So what can we learn from our existing designing operations in order to improve in going forward? And our hypothesis is, may it be that certain misalignments at interfaces happen due to a configuration of how the people are working together, how work is coordinated between activities and people. And this is work that Pedro has done in his PhD. So looking at the different kinds of networks, and we have a number of them in this design here. So this is a CAD model of the engineering of the boiler, the core aspects here. And you can say this is a visualization, so coming back to this idea of the technical aspects. Here you have the subsystems in play, the boiler, air and flue gas, and so on. And of course, there's a number of people involved in doing that. So you could look at multiple connected networks. You could look at the product and its components as a network. You can look at the process through the activities as a network. You can also look at people and organizations through communications. So you have a number of networks, but in reality, of course, this is connected. You can't separate them in order to, as a project control, to really get a hands-on on how you could intervene in going forward. So there's huge, and what is our take? There's huge amount of data being generated anyway. There is activity logs, there are emails, there are engineering documents, and so on. And all this gives us a signature of the project. This gives us an idea of what the activities and what the work is in the company. And so our idea is to ultimately work towards an engineering dashboard, a project engineering dashboard that shows all these patterns of information flow and gives the engineer, but also the project manager, a way of intervening when necessary. And what we've managed to show so far is that there is evidence that the way the activities are connected impacts performance of the company. So we are looking specifically into interface handling, and here, I mean, the opportunities are vast. There's a lot of data, and there's a lot of improvement opportunities that can also be rolled out across different companies. What we're specifically doing and going forward in this area is also to look into the visual modeling of such complex systems. And this is Sebastiano, who has just started his PhD on that as well, coming from a different area. And here, this visualization is almost the same as the one before, except it has, in addition to the product, to the technical side, it has also the people who are working on these design tasks. So you will see in the white nodes, these are the activity groups, boiler and equipment design and so on. And in the color nodes, you have the different departments in the company. And here you can now start to see, how they group around certain activities. Maybe there's higher amount of information flow, maybe not, and so on. But at the same time, you can also start doing what-if scenarios. You can say, okay, what if I take this person out? What happens? How does the network evolve here? Or add. And so these kind of simulations that are starting to become possible now. And I'm sure you all, or many of you know, the sort of mythical man month that works. So if we have an issue we need to solve, often, okay, let's get more people in. Let's fix it. But actually, no, maybe the coordination effect of that will just torpedo what you actually intend to do. So here you could also make those simulations and see, okay, will more work create better results or quite the other way around? So looking at the network roles of designers or other people is one of the areas that we focus on as well. Further, we can also look at the temporal evolution of information flow. It's not shown here on the graph, but you can see that as well. In order, and why do we all do this? I mean, of course, it's to have better project control and execution of projects, but it is also essentially to create more efficiency in an organization, but also to prevent engineering failures. And especially in such a huge, complex product, this is important. I mean, it would cost the money, would cost the company far too much if there's an engineering failure. So from looking at an organizational level, I can take you now a level higher into the industry sector. And there, it's also looking into taking network science aspects and approaches and bringing them to the industry sector. And here, what we can, in simple sentences, say, this idea here is to look at, can we map technological capabilities of companies in order to find ways of collaborating better. So if, for example, as a company, you want to scale up your production, you may want to look at similarly equipped companies with technological capabilities. But you may also want to create new products or new solutions. So maybe you want to actually add different kinds of capabilities. So you need to look at other industry sectors possibly, but how do you do it? How do you select your partners? Often it's through long time knowledge, through history, you know, but maybe you also want to have a way of, in your search and exploration, find new ways that are not yet so clear. So here, a data-driven approach based on software suggestions possibly, or suggestions that are from our heuristics that are programmed into the software could help you here. So this NetSites is using network insights in order to find collaborative, sustainable partners for sustainable production. And I mentioned at the start that this idea of using data to inform research is getting much stronger, and here it certainly is. And I'll give you an example of this. You could say, yeah, you could also call it a matchmaking tool, perhaps. The idea that we had in going a couple of years back, taking some data from State of Green, about 100 clean tech companies in Denmark, to map where they sit on the landscape. And here what you see, I hope the colors are strong enough, is that you have the different technological subsectors. So for example, in the top right-hand corner, you have wind power, all the companies associated with wind power. In here, you'd have energy, solar and other renewables, and so on. And the gray nodes, they are the companies, and the colored nodes are the different energies or different subsectors. So we can see already just from the position in the map that, for example, the wind power sector is quite specialized. And maybe that is due to how Denmark has invested in this industry sector. There may have been some subsidies that have helped the companies to become very, very specialized in their technological capabilities. And now you could say, well, maybe this technological speciality, maybe we actually want to use it in another industry subsector. So what would you do? And here is what we can suggest as, and it's just an example that is hypothetical, absolutely hypothetical. But you could say, for example, let's take the company called, at the time, KK Electronics, and now it's KK Wind Solutions. So they're looking into wind power control systems, designing those control systems. And if we zoom in a little bit, their subsectors they're working on are electronic control systems, but also mechanical components and generators. And then we could say, okay, if we want to scale up production, or if we want to look into similar areas, we could look at other companies that are also connected to those same subsectors. Of course, you'll come into this into the space that these are also competitors, of course. So here, these are some of the companies you could work together with. That would be an idea. But it may actually only give you some incremental innovation. What you may want to do is think through scenarios where the company has an idea of actually expanding into different industry subsector. So from wind power, how do we get to photovoltaics? Can we use maybe some of our capabilities teaming up with other industry partners to get into another industry sector? And here, one option would be to say that actually a company that it seems like the shortest path to a company that is both in the wind power sector as well as in photovoltaics could be Draka. So Draka as a cable supplier with knowledge in both sectors may be a first company that we could approach. It's only, as I said, it's only an example. And Draka in the end may not be the right person or right company to work with, but it may be an entry into that industry sector. So the idea is basically to look through data and see what can we mine, what can we be suggested as engineers and project managers who are looking in their search and exploration phase for collaborative partners. And we're not going to build a clean tech center here in Zealand or wherever it is. We just simply don't have the space, but our tools can create that virtually for you. So having taken you from basically in a journey in engineering systems from application areas such as healthcare to energy, also focusing on the user and designer behavior, but also complexity in an organization and a whole industrial sector, mapping the clean tech sector, from the level of the individual as in level of investigation, to the level of the organization, to the level of the whole industry. I hope I've sketched, and I've only sketched, the surface of the exciting research field, engineering design and engineering systems, and especially designing engineering systems. So this spans, for me, a broad area, and this is really motivating. I think it has a healthy measure of engineering, technology, but also involves and essentially for people in the end, to create better systems to improve people's lives, like yours and mine. So in kind of wrapping this up, I would actually like to also open it up again back to the division. So now I've shown you how, with my expertise in designing engineering systems, I'll contribute to the division and going forward. But I can tell you, we have a lot more in store for you as well. So we have, some of you've seen this now, but we have, for example, projects looking into knowledge sharing between offshore control or offshore and onshore design, offshore operations, onshore design in the maritime sector, looking from a systems ergonomics perspective particularly. There's work into project risk management in wind parks. We have work, especially expertise in project portfolio and program management, for example, in critical infrastructure and construction, and so on. So there is, and risk and uncertainty management. So there is quite a portfolio of activities and expertise here in the team. So before I close, I would like to obviously close with some acknowledgements. As Søren said, it's been a journey. And of course, it's also been a journey in my life. So first and foremost, I would like to say thank you to the research and innovation partners. And there's a selection here. And these are the one we work with closely at the moment. So this is really I mean, also, I see a number of students, or rather former students, I must say, in the audience. And, you know, this is also an open invitation. I mean, they are innovation partners now, research and innovation partners. So this is really a big, big motivator for me, certainly, to connect very closely to application areas, be it with our research, international universities, national universities, be it manufacturing companies, public organizations, consultancies, and so on. So this is the first thank you. And yeah, please approach me if there's further ideas we can come up with. Secondly, of course, thank you to the Engineering Systems Group. And here, yeah, I've shown you the pictures already, but this is the team, the expert team. And then, of course, to friends and family. And this is special for me that my family can be here. So we will celebrate tonight, but then my family will travel home, and I will stay. I will stay at DTU, and I will stay to realize the vision, to create this hub of researchers tackling societal challenges, large-scale complex challenges, transforming society. This is what I do. And then, of course, I'll say thank you to the Rector's Office and to DTU Management Engineering for being given this opportunity. And I'm really looking forward to the years to come. So